In this video, we'll guide you through the process of building a streamlit sepsis prediction app and deploying it on Huggingface. So here we'll start by introducing the sepsis prediction model and the dataset used for training. Then we'll walk you through the process of creating a streamlit app that allows user to input patient data and receive a prediction for sepsis risk. And finally, we'll show you how to deploy the app on Huggingface. So let's get started. Now the codes used in this video are available at this GitHub repository, and the dataset used for the implementation is available in this data folder. First of all, to build a Streamlit app on Huggingface, we need to create a Streamlit space on Huggingface as shown here. So here you can give any name to this space and we'll choose the Streamlit and then public. And after creating the space, click on Files and then click on Create a New File. And after creating a new file, just copy the code for requirements.txt file first and then click on Commit New File to the main below. Similarly, you can copy other codes too. So let's understand what this code is all about. So this code is a file named requirements.txt, which is a list of software packages that needs to be installed to run the Streamlit application. Here the packages are listed one per line along with their specific version. And the file contains 4 packages that are required for the Streamlit app to run. First, it is a Streamlit, which is the main package providing the Streamlit library required for the Streamlit application to function. Then we have extra Streamlit component, which is an extension of Streamlit library that provides additional components for building user interfaces. It is used in the Streamlit application to create more advanced user interface elements. Then we have Streamlit extras, which is another extension of the Streamlit library that provides additional features for building Streamlit application. It is used in the Streamlit application for functionality such as uploading files. Then we have HTTPX AIO cache, and these packages are used for making HTTP requests and caching data. And they are required for the bulk prediction functionality in the Streamlit function. Then we have python.env. This package is used to load the environment variable from the .env file. And it is not directly required for the Streamlit application to run, but it may be used in the project for managing configurations settings. So similarly, we'll copy all the remaining codes which are available at this GitHub repository. For example, if we want to create a footer.py file under the utils folder, we can name it like this, utils /footer.py, and then we'll copy the code and we'll click commit new file to the main. So let's understand all the codes. First, we'll take a code for config.py file. Now this is the Python script for a sepsis prediction app using various machine learning models and the Streamlit for the front end. Here the script loads a historical data set and trains a machine learning model such as AdaBoost, CatBoost, Decision Tree and others. And then the script defines several functions for data processing, model training and prediction. It also includes a main function that creates a Streamlit app and displays various functions including a confusion matrix, ROC curve and a table of patient data. Here the script includes a section of environment management when using a standalone Streamlit server. So overall this script demonstrates a comprehensive approach to sepsis prediction using various machine learning models and Streamlit for user-friendly interfaces. Then we have a code for app.py file. Now this code is a Streamlit application that uses Streamlit components to create a user interface for making predictions on sepsis data. Now we know that Streamlit is a Python library used for creating web-based data analytics and scientific applications, and the code here uses the Streamlit components to create a more interactive user interface. Here the app has 2 main tabs, predict and bulk predict. Now this predict tab allows user to input patient data and receive predictions based on the selected machine learning model, whereas this bulk predict tab enables user to upload a file containing multiple patients data points, receiving prediction for each patient and then download the prediction in a CSV file. And then we have the code, we have defined the utils functions, we have defined other functions here. So here first we will have data loading and pre-processing. So the code will begin by importing the necessary libraries including pandas, plotly, streamlit components. Then it will define several functions for data loading, pre-processing and making predictions. Then we have a navigation sidebar and user interface. We know that the main part of the code creates a series of functions to handle the navigation sidebar and user interfaces. So this navigation function will create a navigation bar with 2 tabs, predict and bulk predict. Then we'll have select model, which will allow the user to select the machine learning from the drop down menu. Then we have some AND points. So this AND points takes a selected model, return the corresponding API AND points. Then we have do single prediction. Now this do single prediction will process user inputs and post request to the selected endpoint and return the functions. Then we have show prediction. This function takes the prediction and displays it in the streamlit component. And then we have a footer function, which will display a footer with some information. Then we will have a bulk prediction. Now this bulk prediction has its own set of functions to handle the bulk prediction features, and where this bulk load widget class creates a customer file upload components using streamlit components, convert df, takes a pandas data frame, convert it to CSV format, then do bulk predictions, then which retrieves the selected models endpoints, accept the user input from the file uploader, process the data, sends a post request to the models endpoint and return the prediction. Then we have show bulk predictions, which display the bulk prediction in a streamlit component and provides a download function to download the prediction in CSV file. And then we have a main function, where the main function ties everything together by creating the streamlit app, displaying the title, handling the navigation and calling the appropriate function based on the selected tab. So to summarize this, we can say that this code creates a streamlit app that allows user to input patient data, select a machine learning model for prediction and receive predictions either for single patient or for multiple patients. And the app also provides options to download the prediction in a CSV file. Then we have a code for Docker file. Now this code is a Docker file that sets up a container for the Streamlit application. We know that Docker file is used to automate the process of creating Docker images, which can be used to run the applications in containers. So this Docker file contains several commands that performs all these operations. First, it copies the requirements.txt file to container, update the pip package manager to the latest version, then install the required packages listed in requirements.txt, then creates a dictionary for the client's front-end files, sets the working directory to the client's front-end directory, copies the front-end files to the container, exposes this port 8501, which is used by the Streamlit application, define the command to run the Streamlit application. So basically this Docker file is used to build a Docker image using a command like docker build, so which will create an image with a specified name and tag, and then image can be run in a container using the command like docker run, and the container will then run the Streamlit application on port say 8501, allowing the application to be accessed by user. Then we have a code for history.py file. Now this code is a Streamlit application that displays the history of predictions made by another Streamlit application. Here the code imports several libraries including Streamlit library, additional Streamlit components, asyncio, AIO cache, pandas, and some utility functions for navigation and footer. Then here the set page configuration is used to configure the appearance of the Streamlit page, such as the page title, icon, layout and sidebar. Then get history function is decorated with @cached, which is from the AIO cache, and this decorator caches the results of the function call and returns the cache results if the same arguments are passed, again avoiding the need to calculate the results. Then we have a main function, which is the main entry point for Streamlit application. So it first sets the title of the page to prediction history, and then it calls a navigation function to display the navigation function. And after that, the get history function is called and the result is stored in df history variable. So if the df history is not none, it means the history file was loaded successfully. So here the data frame explorer function is used to display the data frame in interactive way. So if the history file could not be loaded, then a message is displayed informing the user that there is no history file yet. And then a footer function is called to display the footer at the bottom of the page. So if name main block at the end of the file is a standard way to ensure that the code within the block is executed only when the script is run directly and not when it is imported as a module. So here it runs as a asyncio.run main function, which sets up an event loop and runs the main function, and this allows a Streamlit application to be run and displayed in a web browser. And then we have a code for config.toml file, which is typically used to store the global settings for Python project. And in this particular case, it is named config.tml and is used for Streamlit application. Here the configuration settings are nested under the client section. The show sidebar navigation setting is a boolean value that determines whether the sidebar navigation is visible or not. So here it is set to false. So to use the settings in your Python code, you would typically read the config.toml file using the library like toml, which will allow you to access the values in the configuration file and use them within your application. Then we have a code for footer.py. Now this code defines a function called footer that returns a footer for your Streamlit application, and this footer is a combination of HTML and CSS code. Here the HTML part contains a copyright message with a link to the creator's LinkedIn profile, and the CSS part is used to style the footer, such as setting its position at the bottom of the page, making its full width and giving it shadow. Then st.markdown function is called with the footer HTML CSS code, and the unsafe allow HTML is true parameter, which ensures that HTML and CSS is rendered correctly in the Streamlit application. So by returning this footer in the footer function, you can call this function in your main Streamlit app to add a customer footer to the bottom of your application. Then we have a code for janitor.py. Now this code defines a janitor class that contains several methods to clean the pandas data frame. Now clean data frame method applies all the cleaning procedure in sequence to the input data frame, returns the clean data frame. The other methods are used to perform specific cleaning tasks such as dropping duplicates, converting column names to snake case, replacing certain files with nan, fixing data types, and dropping the rows with the missing values in the target column. So here this janitor class is designed to be used as a utility class to clean the data frames. You can create an instance of the class, pass your data frame to the clean data frame method, and it will return a clean version of the data frame. Then we have a navigation.py. Now this code creates a navigation function using the Streamlit as stimport. This function defines two page links elements in the Streamlit sidebar. So page link creates a clickable link in the sidebar that allows a user to navigate to the specific page in your Streamlit app. So the first page link points to app.py, labels the link as home with an icon. Then second page link points to history.py, connects a link as history with this icon. So here the function also creates a divider in the sidebar, which is a vertical line that helps separate sections in the sidebar. So by calling this navigation function in your Streamlit app, you will have a sidebar with two links and a divider. So when you'll click on the home link, will navigate the user to app.py, and when you'll click on the history link, it will navigate the user to the page history.py. So by creating all the files, will reach to the stage where our model will start building. So if all goes well, then you can start testing the app by providing the different inputs to predict. But if not, then make sure that you have named all the files like this. Okay, so if your app is running well, then you will be able to predict the results by providing the inputs like this. Thank you.